the next function we will see is deletion at the end. So for insertion at the end, we saw two techniques. One is the usual one where you have the head pointer, you traverse throughout and then you add. The other is using a tail pointer, direct after the tail you add one element. Now for deletion, the tail technique does not work in a singly linked list because given the tail, I cannot move in reverse. Like I said, in a linked list, you only have a connection to the next element. In a singly linked list, you don't have a connection to the previous element, so you cannot move in reverse. And so deletion at the end or deletion at any position is not possible if only the tail pointer is given. You definitely need a head pointer to perform deletion in a singly linked list. So with that caveat out of the way, we'll start. So given head pointer, again our objective is to delete at the end. You create a new node called current, you assign current is equal to head, you start traversing. While cur of next is not null, you move to the next node. So what is this? So we saw while cur of next is not null means you're checking for the last node. So if you're doing cur of next is not null, you're checking for the second last node. And why is it important to check for the second last node? Because I will go to the last node and I will free it up, but I need my tail pointer to now point to the second last node, right? So we need to stop traversing when we reach the second last node. We assign that as the tail and then we free up the subsequent node. Again, we'll go back to the picture, it makes more sense that way. So I am here, this let's say is my last node. I want to delete this, but I also want my tail to point to this. So I will assign this as cur, this is my head. I will keep cur of next is not null. So cur is 100, cur of next is 200, 200 of next is 300. So it is not null. So this is not the second last node. So you move to the next node. Now cur is 200, 200 of next is 300, 300 of next is 400. Not null. This is also not the second last node. So you move. Again, this is cur is 300 now, and assume this is my last node, so you have a null here instead of the 500. So my cur is 300, cur of next is 400, 400 of next is a null over here under the assumption that this is my last node. So I have reached the second last node. Now what I do, I set tail equals cur, new node equals cur of next. So now this is my tail pointer, and this is, I am referring to this as new node. Now what I do is free of new node. So this memory is cleared up. Now my memory looks like 10, my list looks like 10, 20, 30. So that's how you delete at the end in a singly linked list. Starting from the first node, you go up to the second last node, you make tail point to the second last node, then the final node, which is what comes after the second last, you free it up.